Hello everyone, welcome back to another GIS statistics lecture video. And in this lecture video, I want to talk our way through the semivariance equation. So the semivariance equation is actually pretty straightforward. So again, just to sort of reiterate the idea here, we have distance on the x-axis and we have semivariance on the y-axis. And we're hoping to see something that looks like this, where points that are farther apart have a higher semivariance, which means that their values are more dissimilar than points that are closer together. This is sort of the ideal semivariance curve. Right? But how do we actually calculate this semivariance as a function of distance? So you'll often see semivariance denoted with this wonky looking, almost looks kind of like a Y. This is called gamma. This is called gamma. So gamma of some distance is going to be equal to the sum of all points. So we have Zi minus Zj divided by 2 times n sub h. All right, this is it. This is all the equation. Oh, sorry, that's supposed to be squared. That's all this equation has to it. So let's go ahead and break down what we're actually looking at here. Let's start with the easy. Let's start with the terms. Zi, right? This is the value of the ith point, right? We've seen this before. Zj, right? This is the value of the jth point, right? H, right? This H right here, and right here. That is, oh, actually, and right here too, right? This is our distance. Right? This is for a given distance. So what this top part is doing is it's saying for all points that have that distance, right? So in this case, Zi and Z, so point I and point J are h distance apart. Right, we're going to subtract their values and square it. And then we're going to divide by this n sub h. N sub h, or I should say 2n sub h. N sub h, this is really the tricky part. This is essentially the number of sets of points that are h distance apart. I know this seems kind of confusing, but let's say we have a situation like this, and I apologize in advance if my bad drawing makes this more complicated here. But let's say we have point A, we have point B, and we have point C. Right? And again, I apologize for my bad drawing. I'm going to use some math symbols here, and I'm going to say that the distance between A to B is the same as the distance between B and C. Okay, hopefully you're with me so far. So to do this calculation, right, we would do ZA minus ZB, right, because that's one set of points. Then we would also do ZB minus ZC, because these are the same distance apart, right? We would not do, right, we would not do ZA minus ZC, right? This is a no, because this is not the same distance, right? If this distance right here, if we call this H, okay? So we would have one set of points, two sets of points. So in this case, n sub H would equal 2. Hopefully that makes sense. I know this is a little bit confusing. But again, the idea here is that most of the time NH is going to be 1, but in the weird circumstance where you have multiple sets of points that share the same distance, you would then have to account for that. Hopefully this makes sense. The general idea is we're basically taking half of the squared difference in value. Right? That's this generally this will do that. Most of the time, this is going to be the difference in value squared divided by 2. Hopefully that makes sense. I know it's a little confusing. If you have any questions, I encourage you to just watch this video a couple times. Hopefully it sinks in. Hopefully this n sub h sinks in. And if you have any questions, please reach out. Thank you.